Hello. This video presentation is a continuation of graphing radical functions. Yesterday we learned how to graph functions that look like this, right here. First thing we did is we set the radical equal to 0, x minus 1 equals 0, and we found that x is equal to 1, and then y is equal to 2. So we started at 1, 2. And then we went over 1, up 1. From the start, we went over 2, 3, 4, up 2, 5, 6, 7, 8, 9, up 3, and 10, 11, 12, 13, 14, 15, 16, up 1, 2, 3, 4. And our graph looked like this. Well, not quite like that. A little bit better. But what happens if the radical is negative or the x is negative? On both of these, my graph has the exact same starting point. So let's look at the second one. And for this, we're going to make a table of values. So the starting point is the same. X minus 1 equals 0. X is 1. Y is 2. So my x, y table of values we're going to start with 1. We know we have 2. So 1, 2. And then we're going to go over 1 more, just like before. So we'd be at 2. 4 more, that would put us at 5. 9 more, that would be 10. And 16 more would be 17. Now, 2 minus 1, so we have 2 minus the square root of x minus 1, or 2 minus 1. 2 minus 1 is 1. Square root of 1 is 1. We get 1. We put 2 minus square root of 5 minus 1. 2 minus the square root of 4, which is 2, or 0. 2 minus the square root of 10 minus 1. 2 minus the square root of 9. Square root of 9 is 3. We get negative 1. And we should see a pattern here. We went down 1, down 1, down 1. We're going to be at negative 2. So now the x-coordinate is 2. We're at 1. The x-coordinate is 3, 4, 5. We're at 0. The x-coordinate is 10, we're at 5, 6, 7, 8, 9, 10. We're at negative 1. And 17, 11, 12, 13, 14, 15, 16, 17. And our graph looks like that. So the graph has the exact same shape as this graph, but this graph goes up, this graph goes down. So when the radical is negative, graph goes down. Same starting position, same everything. Over 1, down 1. Over 4, down 2. Over 9 from the starting point, down 3. Over 16 from the starting point, down 4. Exact same idea. Now, let's look at this one. All right? Again, same starting point, 1 minus x equals 0. Add x to both sides. X is equal to 1, y is 2. So we're going to go x, y, and 1, 2. Now I want to go over 1, so I'm at 2. But 2 plus the square root of 1 minus x, 2 plus the square root of negative 1, that's an imaginary number. We haven't learned about imaginary numbers. This is not a real number. We're not going to graph it on the Cartesian coordinate plane. This doesn't work. So what do? Well, I'm going to try going the other direction. Instead of going over 1 to the right, I'm going to go over 1 to the left. It's 0. 2 plus the square root of 1 minus 0, 2 plus the square root of 1, or 2 plus 1 is 3. So I have the same starting point, but now 0, I'm at 3. Well, let's try 4 over from positive 1 is negative 3. Positive 1, 0, negative 1, negative 2, negative 3. That's 4 over. 2 plus square root of 1 minus negative 3 minus plus a positive 2 plus the square root of 4, which is 2. We're at 4. Now if I go over 9 from 1, I'm at negative 8. So I have 2 plus the square root of 1 minus negative 8 plus a positive, 2 plus the square root of 9, 2 plus 3 is 5. And if I go over negative, in the negative direction 16, I'm at negative 15. 2 plus the square root of 1 minus negative 15 plus a positive, 2 plus the square root of 16, 2 plus 4 is 6. So at negative 3, 1, 2, 3, I'm at 4. At negative 8, 5, 6, 7, 8, I'm here. And at negative 15, I'm not going to bother. My graph looks like this. So at negative x, the graph goes left instead of right. But everything's the same. Over 1, up 1. Over 4, up 2. Over 9, up 3. Over 16, up 4. So all our graphs, just like with quadratics, have the same shape, just a different starting point, and they either go up, down, left, or actually they can do both. Let's look at one last graph. Y equals 2 minus the square root of negative x plus, let's do it minus. Negative x minus 1. All right, first thing we want to do is find our starting point. Negative x minus 1 equals 0. I add x. X equals, if I add x to both sides, I didn't show it that way. I need to erase this. So if I add x, I'm going to have negative 1 equals x, adding x to both sides. So negative 1, 2. Now, this means my graph will go down. This negative means my graph is going to go down. This negative means it's not going to go down to the right, it's going to go down to the left. So now I go over 1, down 1, over 2, 3, 4, down 2, over 5, 6, 7, 8, 9, down 3, and 10, 11, 12, 13, 14, 15, 16, down 1 more. My graph is going to look like this. If you're not sure, check a point. All right? This point, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This point has an ordered pair of negative 10, negative 1. So if I put y equals 2 minus the square root of the opposite of negative 10 minus 1, I should get negative 1. I should get this negative 1 right here. So this changes the sign of everything inside. I'm sorry, I did that wrong. This parenthesis doesn't go there, goes there. This changes this to a plus. It's the opposite of x, only opposite of x. So then I have 2 minus the square root of 9. 2 minus 3 is in fact negative 1. If you pick a point on your graph and it works, hey, you did it right. All right, this ends our videos for the week. Have a great day, have a great weekend, and I'll see you on Monday.